that Kiro tries to prevent you from generating a bunch of slop all at once. Rather than go straight to code, it encourages you to start in this requirements MD file, which defines things like the user story and acceptance conditions. Then once that plan is in place, it can move on to the design, which is the design document that outlines implementation details like your component structure, your testing conditions. Then once that plan is in place, it can move on to the design, which is
state management. I mean, I'm okay with it. I'm comfortable with that. And I suspect many of you on GTT might be comfortable with that. But a random vibe coder, like that would require that they understand things like states or like state machines and finite automata. I mean,
can move on to the design, which is the design document that outlines implementation details.
Look at all this code. Like, in order to do all this, you have to be able to code. Or at least understand code.
Like your component structure, your testing strategy, error handling strategy, and so on. And then finally, those two documents get combined together to create an implementation plan. Each task will outline the code the AI should write, then you can click this button in the IDE to start it. Overall, the process felt a bit slower, but it does feel like a much more sane approach if you're building something serious or working with a team of multiple people. Overall, it feels like an IDE designed to appeal to developers working in enterprise, where things like design documents and consistent code quality matters. But currently, Kiro is closed source and only powered by Claude, but in the future, they plan to offer other models. Right now, Amazon is offering it for free, so using it's a no-brainer, but only time will tell if it becomes a legit cursor killer. But if you want to harness the full power of AI, you need to understand the math and computer science behind it. And you can do that today for free with Brilliant, the sponsor of today's video. Their How AI Works course teaches you how to build a functioning language model from scratch and lets you experiment with things like feature vectors to edit facial expressions and images. So this hands-on approach to
Ooh. People wanted me to talk more about AI. This looks like this is a variational autoencoder, VAE. You're taking an image, you're doing an encoding dimensionality reduction to reduce the dimensionality of the input layer after layer to get to a reduced set here, which is the core definition of this input. That's the encoding. And then we're going to decode this and see if we can replicate this original image. This is a concrete example, I believe, of a variational autoencoder. Like we were talking about before, the one of these papers, Autoencoders, right? And here we go. This is the beauty, is that if you do enough science and nerdy math and engineering and stuff, what you tend to see is that we will often follow the same types of visual clues and processes that will signal when something is something versus something else. And this is an example. So remember, we were just looking at this, and I was like, whoa, this looks like a variational autoencoder to me. And on top of that, it does image. So remember I was saying VAEs or autoencoders, they essentially function as the identity function. The identity function in math is like you're trying to replicate this thing so it gives you the same value. 7 is equal to 7. There's numerous reasons why this can be valuable if you can do something like this. And so then when this finishes, what we're going to see over here is another image, and that image, if this is successful, should look exactly like this guy. Now, he has this dial where we have a smile intensity, which it seems like this is the thing we want to control. So you can make this 0 or -1 and then +1, and then that should change, hopefully, just the smile. This is one of the things you can do with autoencoders, is that once you can nail down the identity function and you break it down into these parts, then you can say, well, give me the identity, but now make the hair blue. And then if it really deeply understands this, then it could make changes to where this image is mostly the same, but it makes the hair blue. Anyway, so I can't remember what we saw over here. I thought it was a guy with a mustache, but maybe I wasn't paying attention. So this should be someone that looks like this guy with a smile. If this VAE or this autoencoder is working correctly.
Vectors to edit facial expressions and image it.
Okay.
So this
Okay, so I think I was right about the mustache. And look, he is smiling. I don't know what all this other stuff went. I mean, this looks like a real person, and this looks like somebody that I would not want to run into in a dark alley. Because even though he's smiling, I'm not feeling like warm and fuzzies about this. So, but anyway, this diagram here goes back to this diagram here. And notice that I was saying this is the encoding phase, this is the decoding phase. And then in this particular case, what you're seeing is that this is doing a reductionality of these dimensions, but then the middle piece is code. And then over here, then it outputs, because this is about code. Okay, cool. So there we go. Hopefully we all learned at least a tiny bit more about AI on top of all the AI stuff we're learning, like with Kiro and Amazon.
Hands-on approach to learning helps you master challenge.
Well, this is very much how I think about the geometric space of neural networks. Like, I think maybe some of you recall, I constantly will talk about learning as playing Marble Madness. And in Marble Madness, you're like this marble and you're going through all these spaces. For the learning algorithms that you are trying to do with neural networks, what you're trying to generally do is find a global minima. You're trying to find the lowest value in this geometric space. And it can be super hard to do this. I mean, extremely hard. One, because you don't know the map. Right? You don't know what it's not like you're coming in doing this where people show you the map and then we look at it and say, oh, the global minima is right there. I can see it. No, you don't have a map. On top of that, there's no human involved. This is automated. This is all mathematical. So you have to come up with an algorithm that will actually do this type of thing. And this all, I forget the mathematical origins. We'll save this for another discussion, but this is where you get into things like gradient descent, in particular stochastic gradient descent, SGD. And so gradient descent, this is a gradient. You are descending, and it's stochastic in that you don't want it to be deterministic. Why don't you want it to be deterministic gradient descent? Because if you do that, it can get stuck very easily because it always follows the same path. If it's stochastic, it has variability even if it gets stuck. So if it's deterministic, think about it like this. Imagine it gets stuck in this valley and is trying to get out, but it uses the same sort of learning rate and the jump mechanism each time. So what happens is it just oscillates between the left side and the right side. It kind of just jumps and goes here, here, kind of like it jump here, jump here, jump here, jump here. And it would just do this forever. That's what would happen if it was deterministic. So instead, you make it stochastic. Stochasticity is your friend in the right circumstances. Why is stochasticity helpful here? If you get stuck and you start to do the bouncing, the stochasticity will then trigger different types of jumps through different learning rates and different strides and all of this stuff. And then what will happen is you'll get unstuck. On top of that, there's a larger chance that you'll discover potentially more territory because of the stochasticity. And that's too detailed to get into, at least for this one, especially given that I'm getting a little tired-ish, and it's almost like 2 a.m. So, yeah, back to this.
Challenging concepts over time and is proven to be 6 times more effective than watching video lectures. Try everything Brilliant has to offer for free for 30 days by visiting brilliant.org/fireship or scan the QR code on screen to get 20% off an annual premium subscription. This has been the Code Report. Thanks for watching, and I will see you in the next one. Yesterday, out of nowhere.
Yeah. And I think at one point I got Brilliant. I realize this might be a little strange that I'm really drilling into the ad, but from my perspective, it's all the same to me. Like, this could be an ad, this Fireship thing, as far as I'm concerned, and this could be an ad. It whatever it is, it has my attention, and that's all that I think really matters. So in this case, Brilliant has my attention. And so they're trying to sell us something. That's cool. What I'm interested in is whether or not this is helpful. I'm pretty sure I fiddled with this, at least at one point, to understand if this can deliver on its promise. And I recall that I was at least somewhat marginally impressed, minimally. So minimally, I was marginally impressed. It's just been a while since I've looked at it. So it could be that it was better than just marginal. And I wanted to mention this because if some of you on this stream or watching this VOD are trying to learn about mathematics, science, engineering, AI, this might be a good tool to dabble with. I'd also recommend you minimally take a look at like the lectures that I have at the university, because that stuff could be helpful. The problem is 329 is, which is my course, it's pretty advanced, and it sort of assumes that you're already a graduate level computer scientist, AI, mathematician, all this stuff. So I skip a lot of the stuff like stochastic gradient descent and how to deal with saddle points and plateaus and types of learning rates, strides, all of this stuff, various types of machine learning. So it's super, I think the course is valuable if you're deep diving into using AI for code. But if you just want to get a better general sense of AI, my course is just too specialized. I think, so my course is 329M, and I think the 229M, yeah, I think 229. Okay. I thought, or maybe, no. Yeah, this one. $229? Maybe it's just 229. Maybe it's just 229. Yeah. Okay. This. Yeah. So this is so you can kind of see how the numbering system works. So like 129, I think, is the lower level. 229 is the level up. 329 is more advanced. And so this is the general, as I understand it, this is the general machine learning course. So this is like, so this individual, it looks like, teaches this. This is the course that like Andrew Ng used to teach, I think. I think that's right. Oh my gosh, look, this is Ben Spector. This is one of my students. Incredible guy. Absolutely. Yeah. Actually did his undergrad and maybe master's at MIT working with my friend Tim Kroska. Yeah, small world. Anyway, so yeah, maybe someday Ben will be part of Merle. Really love this guy. he took my 329 course the first year that I taught it, and his project was actually the highest voted project for all the students. It was spectacular. I mean, incredible chops on this one. Anyway, I think the point I'm trying to make is this is the course that you would learn about this type of stuff, right? Linear regression, least squares, gradient descent, overfitting, bias variance, linear algebra, regularization, the lasso, validation sets, cross validation. By the way, validation just in general, I don't know, I have issues with. Linear classification, logistic regression, neural networks, naive Bayes, GDA. What is GTA? Okay, like k-means clustering. Is this GMM? I feel like this is this generalized matrix multiply, something like this. Unsupervised learning, or I call this self-supervised. I think that I agree with Jan LeCun that I'm not entirely sure unsupervised learning exists. But self-supervised learning, I think, does exist for sure. Sequence models, recurrent neural networks, long short-term memories, blah, blah, blah. By the way, I'm a huge fan of these things, and I think there's not enough evidence yet to know that sequence models that use recurrence are fully, that they're fully eclipsed by transformer-based models that are sequence models but don't use recurrence. We can get into this in more details. K nearest neighbor. This is really good. Decision trees, bagging, transformers. This is principal component analysis, I think. Yeah. Anyway, this is like this is cool. This is ooh, time series. Ooh. Oh, I might show up for just the final lecture, just because and that was a guest. Maybe I'll ping Ben to see, but I think many of you know I love time series stuff. Ooh, yeah, and it makes sense that they would save it for last, because once you get into time series, whoo, it gets hard. Like, not to say that this other stuff isn't hard, but this other stuff, this is like 2 plus 2. This is like 1 plus 3. Simple. This is, I mean, for almost all of you, if I sat down with you for an hour for each one of these, probably an hour, I mean, with sufficient background, obviously, but with you not knowing any of this, I could probably sit down and teach you the core ideas of all this in like a single sitting. Because this is not hard stuff. Like we just learned about gradient descent, right? Like, remember, we were like, so here's what gradient descent is. This is a gradient, and we're descending. Don't let the word scare you. And there's stochastic and conjugate. Like, stochastic is generally the one that you want to use. Why? Because stochastic is stochastic, right? And they probably get into this. That's why they call it gradient descent, and they don't call it stochastic gradient descent or conjugate gradient descent. They're just gradient descent, because there's different types of gradient descent. Yeah. By the way, Simran, do I know you, Simran? No, it is somebody else. Okay. So anyway, these lectures here, this is not super hard stuff, but this topic, if I tried to sit down with you, not only could I not get through this topic in a single hour, I couldn't get through this topic if I met with you every day for an hour for an entire year. That's how complicated this is. And this is why I am dedicating a large portion of my life to this, is that the likelihood that we'll solve a lot of these like temporal things is approaching zero, which makes it super fun. is any forward progress. Like, okay, cool. We are now 0.001% closer to figuring stuff out. Like, yeah. Hopefully they can figure out sort of like the longevity drug, so I can live to be 200. I don't want to be immortal. I just want to live long enough to make enough forward progress on temporal problems, specifically time dilation and the ability to reason about intentionality and other things over the passage of time. But I guess I'm not allowed to talk about that in too much detail either. So anyway, this is the undergrad general course that is the precursor to my course. So basically, all the students that are in my class, they have to have taken this. It is a core prerequisite for them to take my class. And this is the class that you would learn these fun things in. Cool. All right. We've been going for an hour and 40 minutes. This has been super great. Absolutely love it. Let's check the poll just to see what we've converged on. We had 98 votes. Let's see where we are now. We now have 131 votes, and AI is dominating. So my hope is that this is getting us more on AI. And everybody's feeling like we talked about a lot of AI things. And I'll try, as I move forward, to bounce around between code stuff and then AI stuff. And we might even get into building some AI things. Or I might just start digging into different aspects of AI in terms of what's sort of like actually important for these AI things, which there are model related things that are interesting, like transformers and language models and all that. But the truth is, a large portion of the big challenges that exist in machine learning are in the space of data augmentation. So data augmentation, data curation, data cleaning, stuff that potentially may sound boring, but is often more important than just general model improvements. Yeah. Anyway, excellent. Well, thanks everybody. This was super fun. And we've got the poll going. I may do another poll, but love hearing all your feedback. And I hope we all learned something, and feel free to drop some stuff in the comments. Let me know what you thought, and have a great rest of your day.